Hello, Algebra 1. We are going to start with our next unit, which is special case equations. So we are kind of building off of multi-step equations. So this one is titled Special Case Equations. And I'm just going to start with an example, and then we'll see what that means and kind of talk more about that. So let's look first at this example. So we have 2 times x plus 2 equals 4x plus 1 minus 2x. So first thing, one thing I always like to do is just put that line down the equals sign to help me to remember what I'm doing here. So that just helps. You don't have to do that. If you can keep yourself organized, you don't need to. So what I always want to start with is distribution. So I always want to get rid of the parentheses sign on any equal sign. So that's what I'm going to do. I'm going to distribute this 2 to both x and to 2. So that's going to become 2x plus 4 equals, and then this side had no parentheses, so I don't have to distribute anything. Okay, so now that we've done that, we're going to combine any like terms. So 2x plus 4, nothing there that we can combine. 4x minus 2x, I can combine these. 4x minus 2x, that becomes 2x. So this side is just going to come down, and then we have 2x plus 1. Okay, so then our next step, once we have combined like terms, is to move the variables to one side of the equation. So I'm going to move my variables to the left side. So if this is a plus 2x, to move it to the other side, we're going to apply our inverse operations. So if this is a positive 2x, we're going to subtract 2x here, and then subtract 2x here. Now, hopefully you're recognizing why this is kind of a weird one. 2x minus 2x, wait, that's 0. So that cancels, and then the 4 comes down. And then over here, 2x minus 2x is 0. That's actually what we wanted. That was our plan. And so equals 1. So now my variables are gone, and I'm left with just numbers. 4 is equal to 1. Now, is that true? Is 4 equal to 1? No, that's not. That's a false statement. So what that means for this equation is there is no solution. There is no value that I can plug in for x that is going to make this equation work out. So my answer here is no solution. And so that's one of our special type equations, or special case equations. So what no solution means is there is no possible value that can be plugged in for x that will work for this equation. So there is no possible value that can be plugged in for x that will work for this equation. So that's what it means when there is no solution. Okay, let's look at a second type of example, and then we are going to go kind of review what we're seeing. So let's look at another example. If I gave you -5 minus 9x equals 3 times 1 minus 3x minus 8. Okay, so your first thought, hopefully we're thinking, what's our first step here? First step is to distribute. So I'm just going to draw my line down the center, and I'm going to distribute the 3. I'm going to distribute the 3 to the 1 and to the negative 3x. So we have negative 5 minus 9x. 3 times 1 is 3. 3 times negative 3 is negative 9x minus 8. I am then going to combine like terms on each side of the equal sign. So negative 5 and 9x, those can't combine. 3 minus 9x minus 8, 3 and negative 8 can combine. 3 minus 8 is negative 5. So I'm just going to bring this side down. And then we have negative 9x minus 5, because 3 minus 8 is negative 5. Okay, so then my next step, which I'm sure some of you guys are seeing what's going to happen here, my next step is to get the variables on one side of the equation. So I'm going to move this negative 9x to my left side. Because it's a negative 9x, to do the opposite and move it over, we're going to add 9x to both sides. And what happens? Well, on this side, we have the negative 5 comes down. Negative 9x plus 9x cancels. 0, right? Negative 9 plus 0, or plus 9 is 0. Same here. Negative 9 plus 9 is 0. So 0x goes away. And then negative 5. So I'm left with negative 5 equals negative 5. Is that a false statement like we had over here? No. 4 doesn't equal 1. But negative 5 does equal negative 5. This is a true statement. So what that means here are there are infinitely many solutions. And often you will just see me write IMS, but infinitely many solutions. And so what that means, so where no solutions means there is no possible value that can be plugged in for x. With infinitely many solutions, that means any value can be plugged into the equation for x and it will work. Oops. Equation for x and it will work. So that means I can plug in 2 in here and I will get an answer. Like it will come out to work. I can plug in 0 here and it will equal on both sides. I can plug in negative 1 in both of my x values and it will be the same on both sides. So no matter what number I put in, I will put, like it will always work out to be equal on both sides of the equal sign. So these are both called special case equations. So what's similar to both of these, and in both situations, the variables canceled out. So let's write a few notes on that. So when solving an equation and all the variables cancel out, it is a special case equation. And a special case equation, okay, so it's a special case equation. Sorry if I sounded discombobulated there. Did someone come in and then I got confused, so. Okay, so when solving an equation and all the variables cancel out, it is a special case equation. And so there are 2 types. One where there is no solution. And no solution is when you are left with a false statement. Like we were up here, 4 doesn't equal 1. That doesn't make sense. So like if I had left 10 equals 8. That doesn't make sense. That's a false statement. Whereas infinitely many solutions, or often, like I said, I'll write it as IMS, is when you are left with a true statement. So an example of a true statement like 3 equals 3. Or up here, -5 equals -5. So kind of just to summarize that, this is super important when it comes to special case equations and knowing this information. So when all the variables cancel out, it is a special case equation. So no solution is when you're left with a false statement. Infinitely many solutions is when you're left with a true statement. Super important, and we'll do some more practice with those. So let's do another example. So number 3 is 3 times 2x plus 2 minus 3x equals 6 plus 3x. Okay, I want you guys to try the first step on your own. So think about what would be your first step that you guys would apply here. So pause me, think about this on your own, and then come back and check your work. Just do the first step. So your first step would be to just distribute that 3. So 3 times 2x is 6x. 3 times 2 is 6 minus 3x equals 6 plus 3x. Okay, so from there, I want you guys to think about what's your next step here. So pause me again here, try the next step, and then come back to check to make sure you're on track. So if your next step was to combine like terms, you would be correct. So we can combine like terms on the left-hand side. 6x minus 3x is 3x. And then we're just going to bring down that 6. And then what would be our next step? So our next step would be to get the variables on one side of the equation. And I'm sure some of you guys are already seeing what's going on here. We're going to move the 3x. It's positive, so I'm subtracting it. And what happens, 3x minus 3x is 0, goes away. We bring this 6 down. Bring this 6 down. 3x minus 3x is 0 again. It cancels out. So we're left with 6 equals 6. Is that a true statement or is that a false statement? It's a true statement. So when it's a true statement, it's infinitely many solutions. And again, I just write IMS. Okay, so let's try another one. So you have 3x minus 13 equals 7 times x plus 2 minus 4 times x minus 1. Okay, so think about, again, what would be your first step? So what's your first process here when you guys would start to solve this? Now your first step is always to distribute. With this one, we have 2 sets of distributing that we have to do. So the 3x minus 13 comes down. The 7 is on the outside of the first set of parentheses, so it's 7x plus 14. And then the negative 4 is on the outside of the second set of parentheses, so it's negative 4x plus 4. So the 7 got distributed to the x plus 2, and the negative 4 gets distributed to the x minus 1. Okay, now again, go through with your second step. So pause me here, do your second step, and then come back, check your work. So your second step should be to combine like terms. There aren't any like terms on the left-hand side, so we're just going to bring that down. But the 7x and the minus 4x can combine to become 3x, and the 14 plus 4 can combine to become 18. So from there, we start to solve. So we have a positive 3x I'm going to move that to the other side. I'm going to subtract 3x. And some of you guys can see what's going to happen before we do this, and that's fine. If you get here and you're like, I know what the answer is going to be, great. If you need to go that one extra step, go that extra step. So 3x minus 3x is 0. We bring down that negative 13 equals 3x minus 3x is 0. We bring down that 18. Does negative 13 equal 18? Is that a true statement or a false statement? Well, that's a false statement. Those do not equal each other. So this one, when it's a false statement, it's no solution. Okay, let's do one more and then we will be done for today. Okay, so number 5, we are going to do 8 times 5x minus 3 equals 6 times negative 3x minus 4. Okay, so I want you guys to kind of start this process on your own. If you guys want to pause me here and start the process, you guys can do step 1. I'm going to break it down a little bit, do it just step by step, but you guys can start this one, pause me here, and then come back just to check your work. Okay, so your first step is always to distribute. 8 times 5x is 40x. 8 times negative 3 is negative 24. 6 times negative 3x is negative 18x, and 6 times negative 4 is negative 24. Okay, so my next step then would be to combine like terms. My like terms are already combined. There are no like terms on the left, there are no like terms on the right, so I'm good. So now what I'm going to do is just move my variables to one side of the equation. I'm going to move this negative 18x to the other side of the equation. So I am going to add 18x over here. And you're probably thinking, wait, this is a little different than the last 4 that we have done. And you're right. 40x plus 18x is 58x. The variables aren't canceling here. This is really not a special case equation. Negative 18x plus 18x is 0. And then negative 24 comes down. So once we've moved the variables to one side of the equation and we still have variables, we need to now move the constants to the other side. So my constants are the numbers without the variable. So I'm going to move this negative 24 to the other side by adding. So I'm going to add 24 to both sides. And I'm going to bring this over here. So that 58x is going to come down. Negative 24 plus 24 is 0 equals, wait, negative 24 plus 24 is also 0. Now, this is where a lot of you guys get tripped up because you think that, wait, this is going to be a no solution or an infinitely many solution, but you're wrong because we still have a variable in our answer. So we can keep solving this further. To get x by itself, I would divide both sides by 58. 58 divided by 58 is 1x, which is what we want. And 0 divided by 58, well, 0 divided by any number is 0. So I still get a solution. I still get a solution of 0. It's not saying that no value works out. It's not saying that any value works out. It's saying that if I plug in 0, that's what works out here. So that is our last example. If you guys have any questions, we'll do some practice in class. But make sure you guys are bringing your questions to class so we can review as much as possible so you guys feel as comfortable with this as you can. I hope you guys have a great day, and I will see you guys soon. Bye, guys.